Hello everybody. In this video, I am going to explain you one more very important form of integration. It's very important for the board examination and any competitive examination as well. Let us see the form. If our integration is of the form a sin x plus minus b cos x, this is plus or minus, and on the denominator c sin x plus minus d cos x. See the form of the integration where a, b, c, d belong to any real number. Now we have one more form number 1 or form number 2. If our integration is of the form a sin x plus minus b cos x plus minus c whole upon d sin x plus minus e cos x plus minus f. Look at the form of the integration. Here a, b, c, d, e, f, all these are real numbers. It may be any real number. Okay. Now let us see the process to solve such integration. How we should start this? Here we have to let our numerator as numerator equal to a times differentiation of denominator, whole complete denominator, a times differentiation of whole denominator plus b as it is. B as it is taking as denominator. This is the way of taking supposing our numerator. Now let's start with an example. Suppose make any question 2 sin x plus 3 cos x upon 4 sin x minus 5 cos x. Suppose this is our question. So as the process says, how we should start, we should let our numerator as 2 sin x plus 3 cos x equal to a times the differentiation of denominator, that will give you 4 cos x plus 5 sin x, okay, and plus b denominator as it is. Just put here the denominator as it is without changing its value. Now in the next step we have to find the value of a and b by comparing both sides. So how we should do? Just open all the bracket, 4a cos x plus 5a sin x, 4b sin x minus 5b cos x. Take sin x common, we would have 5a plus 4b. Take cos x common, we would have 4a minus 5b. Now if you comparing both side, on comparing both side we would get the coefficient of sin x as 2 equal to 5a plus 4b, and if you compare the cos x both side we would get 4a minus 5b equal to, we have the coefficient here as 3. Now we have to find the value of a and b. Let's see. I am writing here 5a plus 4b equal to 2. Now let us make the coefficient same to eliminate one of the variable. So what should be the better value? Let's multiply it by 4 and multiply it by 5. We would get 16a minus 20b equal to 12 and 25a plus 20b equal to 10. Fine. Just add both the equations so that to cancel the b we are remaining with 41a equal to 32. So the value of a we obtained as 32 by 41. Fine. Since we got the value of a, we can easily find the value of b by substituting the value of a here. 5 times 32 by 41 plus 4b equal to 2. So 2 minus 10, 5 to 16 by 41 equal to 4b 82 minus 160 by 41 equal to 4b. We are remaining with b equal to 1 by 4 times by 41, and here we would have 80 and 80, so 78. Okay, so this is the value of our b, minus 78 upon 164. We may get such a term in such problem, so it's a constant term, so we have nothing to worry about it. Now we have our I as this. We will write as I becomes as usual. So you have taken your numerator as this, so just substitute the value of numerator as we have supposed here. So our I becomes, this will replaced with this by putting the value of a and b what we have obtained here. So we will get like a, the value of a is 32 by 41 times 4 cos x plus 5 sin x, and plus b, b stand for minus 78 by 164. You can also simplify like 2 3 is 6, 39, or 2 39 by 82. We should write here 39 by 82 because it's already very bigger term, into the denominator as it is. So just put here the denominator term. We have 4 sin x minus 5 cos x, and the denominator as it is 4 sin x minus 5 cos x. Just split into two integral. We will be remaining with 32 by 41, this divided by this, that would be cancelled, remaining with x only, minus 39 by 82. Here sorry, there is a mistake. Second term would be cancelled, not the first term, because the terms is little bit different. 4 cos x plus 5 sin x upon 4 sin x minus 5 cos x. This is our first integral, and the second integral would be 4 sin x minus 5 cos x upon 4 sin x minus 5 cos x. It is cancelled here. This is our second part, which is remaining as 1, and the integration of 1 is x. Now what's about the first integral? Here if we see, the numerator is the differentiation of denominator, so we just let 4 sin x minus 5 cos x is equal to t. After differentiation we will get 4 cos x plus 5 sin x dx equal to dt. Our I becomes 32 by 41. Now it is going to over, so don't worry. Okay, 1 by t. So our final answer is log of t. I am just skipping one step. I just put the value of t what we have taken, 4 sin x minus 5 cos x minus 39 by 82 x plus c as the final solution. So this is the process. Basically the step is very easy. Just we have to let our numerator like this, and our supposing our value, just we compare the value on both sides to get the value of a and b. After putting the value of a and b on the integral, we just split into two parts. We will get two integral, I1 and I2. I1 can be easily simplified using the method of substitution, and I2 get cancelled to get the value of 1. Now if we get the question of the form number 2, how we should proceed here? We should start with let our numerator as a sin x plus minus b cos x plus minus c is equal to a times differentiation of denominator plus b times denominator as it is plus one more variable would be there, c. And the next step is completely same, to get the value of a, b and c by comparing both sides. After getting the value of a, b and c, you will split into the three different integral. Okay, the first one would be solved by the method of substitution. The second one would be solved by completely cancelling the term, because see here the denominator is same, it would be cancelled, and the third integral I3, this is I2, this is I1, the I3 would be solved by the method of one of the smart integral form I have given. I forgot on which slides I have given this thing. I think it would be number 4 or 5. You can get the solution from there. So the whole integral can be done using this manner. Okay, I hope you understood the solution. If you have any query, you can ask anytime through email, through WhatsApp, or through the comment section. You can also take online tuitions through me as a live mode. Okay, I use BitPaper, Zoom Cloud meetings for sharing the content. Okay. Kindly like, comment and subscribe my channel. Thank you so much.